Hello everyone, I am Rajitha Warusavitarana, a Google Summer of Code student of Scholar organization this year. And this demo consists of two parts. The first part is about the NodeCloud project, and the second part we are deeply focusing on the code generation tool of the NodeCloud project, where I have the main contribution in this 2.0 release. So if we look at the project structure, previously we had the NodeCloud core and plugins in separate repositories, but now we are using Lerna to structure this repo as a monorepo, and then we have brought all the NodeCloud plugins and the core in the same repository. And if you haven't heard about NodeCloud before, let's start with the basic introduction. So NodeCloud is a standard library where we abstract the cloud API to easily manage and access different cloud providers. So if you are working on a project which uses multiple cloud providers, or you need abstract cloud API where you think that you can easily switch between cloud providers in the future, NodeCloud is a great solution. Also, if you are open source enthusiast who is into cloud engineering or code generation, this is a great project that you will like to contribute to. So moving forward, currently we support AWS, Azure, Google Cloud Digital Ocean and NodeCloud, but currently we have only automated the process of generating JavaScript classes for AWS, Azure and Google Cloud. Configuring NodeCloud is the same, where you just need to create an nc.config.js file and add necessary information like name, tag, plugin, config path as shown in this example to interact with different cloud providers. So let's look into a example project that I have created. This is the sample project that I have created, and as you can see, I have imported some plugins and configured the NodeCloud config. So if you are going to try this out, currently since we haven't pushed our packages to npm, you wouldn't be able to directly install this through npm or yarn. So if you are trying this out by any chance, just go to our GitHub repository and then clone it, and then you can plug NodeCloud to your project using symlinks, using yarn links. So npm links, where I have documented here, where you can use symlinks to plug NodeCloud to any project. So let's look into this example that I have written, where I have imported the NodeCloud command module, and then I am using the compute module of AWS, and I have also written the functions to launch and stop an instance. So let's run the launch instance function. So now we should be able to see an instance launching in AWS. This instance is pending. And yes, the instance is running. So let's stop the instance as well. ID. Yeah, now it should stop the instance. So this is something NodeCloud was having for a while, where you can interact with different cloud providers in abstract way. For example, if I want to get the compute module of GCP, I just need to change this to GCP and execute the function. So as it was there for a long time back, I'm not going to deeply explain you on this. Instead, I will be explaining you more about the NodeCloud project, and I will be explaining you about the code generation process. So as you can see, our repository, we have packages, and we have a generator, and we have the docs file, and we also have some JSON file for configurations. And starting on with learner, we have set up learner with yarn using our workspaces, and the packages directory, which is this, is managed through learner. So currently we have learner commands at toolinting, testing, running prettier. We have already set them. So once you run tests, it will run all the tests available under the learner managed packages. So moving forward, we have the generator, which is our primary concern in this demo. So this generator consists of three main parts, which is the parsers, the generators where we extract data, and the transformer. So let's start with parsers, which is the simple part of this generator. So we have three parsers for AWS, Azure, and Google. So what it does is, it reads a file from the SDK, in the sense from here in node modules we have the AWS SDK. So it basically read these clients. For example, if I am generating a service class for Amplify, it will read this file, and it will then make this to an abstract syntax tree and pass it to the generator of AWS, which is here we have the generator of AWS. So what it does is basically get this type definition file in the SDK of Azure or AWS or Google Cloud, whatever it is. This parser part is making it an abstract syntax tree and sending it to the generator right there. So if we go to the generator, here we have lots of things going. So mainly we extract all the data from the abstract syntax tree, and then we also initiates the transformation function here, and then we print our generated code in generated classes. So we have a generated class for AWS, Azure and Google Cloud here. So if we go to the AWS generator, main function we have here is the extract Sdk data method. So what we do here is we traverse through the abstract syntax tree and we collect all the required data for our transform, which means we traverse through the nodes of the abstract syntax tree, and we get the method names, method parameters, return types, everything we collect here. So if you haven't seen an abstract syntax tree, it is something like this. So we have different nodes here, function nodes, class nodes and everything. So we can using this abstract syntax tree, we can extract the data we want for our transformation. So even the transformation function, what actually happens is we have dummy classes which are kind of the format of AWS service, and Azure we have a different format. So we have the formats here set up here. What we do is we pass this dummy and we do a transformation to achieve our goal. So that happens in the transformation part. I will talk that afterwards. So for this implementation, what we are using is the TypeScript compile API, where we use different methods of TypeScript, where we do parse and to traverse to extract everything. We use the TypeScript compile API. Without staying any longer, we will run the generator and see what happens. So since we are using TypeScript here, the command for execution is tsc. So we have this main file here. So in this main.ts file, what we do is we read the NodeCloud YAML file. The NodeCloud, after reading the NodeCloud YAML file, we get some information from there, and we direct it to the different generators. The NodeCloud YAML file contains services and the providers and their methods. For example, this is the storage bucket service. So we have AWS, Azure and GCP, and the methods, the NodeCloud function methods for creating a storage bucket is create, and it can be different in different cloud providers. For example, AWS, it is create bucket, and Azure, it is create. And if you see another example, this is parse, which is platform as service in AWS, and we also have the Azure here. So it's actually elastic beanstalk in AWS, and Azure it is the app service. So here in AWS, the method name is create application, and Azure it is create or update. So what we do is we have listed all the DTS file names and the methods and the target method of the NodeCloud service. So if we check the generated classes now, again, all it was already there. Let me delete this and run this again. So as you can see, we have nothing here, and I'm running this again. So we got all the generated services. These are totally auto generated using TypeScript compile API. So this NodeCloud.yaml file is very important. This is where we state everything that we need that needs to be generated. So if you need to integrate a new service to NodeCloud, what you need to do is add this service to NodeCloud YAML and give all the necessary details here, and the generator component will generate the service. So after generating this service, you can see it contains all the necessary methods, even the GSoC comments to auto generate the code. So to find out more information about the generator and parsers, read my articles which is published on Leopard's Lab publication, where I have written a lot of details regarding the NodeCloud YAML structure and all for different cloud providers. For example, for GCP we have two formats, which is the client driven format and the class driven format. For example, in the class driven format we normally specify the main class of it, and in the client driven format we specify versions and all to get information to read the SDK. So that's about the NodeCloud YAML file, and let's move into the transformers, which is the very important part. So when we are moving into transformers, we have 4 transformers, one for AWS, one for Azure, and 2 for GCP, where we have the client based transform and the class based transform for Google Cloud. In the transformer we have 3 transformations. These are different for different cloud providers, and the first one is add functions, the second one is add identifiers, the third one is add comments. So the add functions transformation, what it does is it takes this dummy class and the dummy method, and it populates the functions. Like for example, if we have 8 functions, it will create 8 functions with the function name and the basic stuff. So it creates the basic structure, and then the identifiers, like what are the class names, what are the methods names. So it goes through the dummy structure of it and fills it out with the identifiers. And finally we have the comment generation, where we add the category, whether it's AWS or Azure, what kind of type of class is it, and then we set up the parameter comments, and then we add the multi-line comment above our methods. So after that we can using these comments, we can generate the API documentation using yarn-doc. So what we are using here is GSoC. So if you type yarn-doc, it will automatically generate the files required for the API documentation. So if you check the index HTML file, if you open this, so here we get the generated API documentation, where we have the root readme here, and all the classes are mentioned here with the parameter types, methods and everything. We have it here. if we go back to our transformers, this is the Azure transformer, which is not much different compared to AWS, but one main difference is that we are setting imports there, because Azure has different SDKs for different services, where AWS has only one SDK for every service. So in Azure we have to read multiple SDKs, so the data extraction function is a bit different, and also the transformation function is different, because we need to add several imports. For example, if we take the generated class for AWS one, Azure one, we have this client going on here, so we have to set up these clients in Azure, and in GCP also we have to do the same. So it's a bit different, and the most complicated one would be the Google Cloud, because the SDKs of Google Cloud are not much consistent, so we have to run several transformers based on this SDK type. So currently we have the client-based transform and the class-based transform, and using those we have generated many service classes here, and now these service classes are used in our plugins. So if you go back to the plugins, AWS plugin, so we have put them here, and I have updated the AWS class with those, and they are ready to use. All the generated services from the generator of AWS, Azure and Google Cloud are ready to use. So that's all about the code generation and the new learner structure of NodeCloud. Thank you very much for watching this video.